Hi, this is Mr. Riley's Maths Videos, and this is my first video introducing complex numbers. There are other complex numbers videos on our channel, but they're a bit more complicated, so this is just very quickly in a 5-minute video covering some of the key ideas, especially for those that have missed classes over the last few days. So here we have complex numbers as a whole new topic. There's a whole question on it in the Leaving Cert, standalone question, which is great. It doesn't involve other topics. It's very like algebra, so it's quite a nice one to do if you like algebra. There's two key ideas in it. One of the ideas is that they came up with a way to deal with negative numbers having a square root. So if you remember when we did the minus b formula in other times and we ended up with a negative number under the square root, we'd always say, oh, that's an error. You must have done something wrong, it can't work or whatever. And what we've found now is that actually there is a way of dealing with negative numbers under the square root, and this is the idea. They decided to call the square root of minus 1 I. So the square root of minus 1 is represented by the letter I. What that means is that any number that's a negative number can be represented with a certain number of i's. So if we had minus 4, square root of minus 4, that's actually using the rules of surds, which we'll look at again. That's actually the same as 4 times minus 1. So negative 4 is the same as 4 times minus 1, which is the same as the square root of 4 times the square root of minus 1, which is equal to 2. And then, of course, that's I, so 2 times I. Now, you don't have to be able to do this. It's just good to remember and realize where 2i is coming from for the square root of minus 4. All you need to be able to do is to recognize that the square root of minus 9 is 3i, the square root of minus 16 is 4i, the square root of minus 25 is 5i. You can see where this is going. The square root of minus 36 is 6i, the square root of minus 49 is 7i, the square root of minus 64 is 8i, and so on. The square root of minus 100 is 10i, the square root of minus 144 is 12i. So to find the square root of a minus number, we just square root the number and make it that number of I. Now, if the square root of minus 1 is I, if I square both sides, so what I've got, I is equal to the square root of minus 1. If I square both sides, I get I squared here. And if I square the square root of minus 1, they cancel each other out and I'm left with minus 1. So as well as the square root of minus 1 being I squared is minus 1. And this is perhaps even more critical, because when we come to multiply complex numbers, we have to deal with this. So wherever you see an I squared, you're thinking, oh, that's minus 1. And if I multiplied I squared by anything else, say I multiplied it by 2, that would be 2 times minus 1, which would be minus 2. Okay, 3i squared means 3 times I squared, so that would be minus 3, because it's 3 times minus 1. 5i squared would be minus 5. 20i squared would be minus 20. And if you have a negative number, let's say negative 8i squared, well, that's the same as negative 8 times negative 1, which is plus 8. So negative 30i squared is actually plus 30. And this is really important, as I say, when you come to dealing with multiplying. Okay? That when you have an I squared, it's minus 1. And when it's multiplying by a number, like 3i squared or 50i squared or whatever, it's multiplying it by minus 1. The next thing to notice is that complex numbers all have a real part and an imaginary part, and we're going to plot them in a minute. Okay, I have a graph here to plot. So a real part and an imaginary part. What do I mean by that? Well, if you look at these complex numbers here, 3 plus 4i, 1 plus 2i, minus 3 minus 2i, each of these has a real part, which is the number without an I, and an imaginary part, which is the number with the I. So that's real. And sometimes we call it, just to save writing so much, we call it RE for real and IM for imaginary. So that's the real part 1, that's the imaginary part. Minus 3 is the real part, minus 2i is the imaginary part. Minus 5 is the real part, and 3i is the imaginary part. 0 is the real part, minus 4i is the imaginary part. 4 is the real part, 0i is the imaginary part. So any complex number we have has a real part and an imaginary part. Even if some of them are zeros, there's still a real part and an imaginary part. When we come to plot those complex numbers, let's just write them down here. 1 plus 2i minus 3 minus 2i minus 5 plus 3i, 0 minus 4i, and 4 plus 0i. When we come to plot those, we plot them like we do in coordinate geometry. We have two axes. We have a real axis and an imaginary axis. Now if you notice, the imaginary axis has i's all the way along it, and i's sound like y. So I, y, I and y. Okay, so when you think y-axis, you're thinking imaginary axis, and that leaves the real axis to be the x-axis. Okay, so the horizontal axis is the real axis. It's going to have the real numbers. The imaginary axis, the I-axis, is the y-axis. It's going to have the imaginary numbers. So if I have 5 plus 2i like this, 5 plus 2i is 5, because that's real, that's imaginary. 5 on the real axis, 2i on the imaginary axis, and it's plotted there. 3 plus 4i is 3 on the real axis and 4i. 3 plus 4i. 1 plus 2i is there, because it's 1 on the real axis and 2i on the imaginary. Minus 5 plus 3i will be up here. Minus 5 plus 3i. Minus 3 minus 2i is down to there and across from there. So here, 0 minus 4i means 0 on the real axis. So 0 on the real axis is here. Minus 4i is down here. So that's 0 minus 4i, and 4 plus 0i, there's 4 on the real axis and 0 on the imaginary axis, so that's 4 plus 0i. Okay, that was a really quick introduction. The next video is about adding and subtracting complex numbers. Bye.